Morning. So, thank you, Magda. It's good to be back here at XLDB. So, let me get into this quickly. As Magda noted, we actually have a wide array of data-related services and products. And the part I'm going to be talking about the most today is what we call the Cortana Intelligence Suite, which is kind of a happy meal for all kinds of data-related services. I'll go into that shortly. It includes, among other things, Hadoop, the data lake, and our offerings in machine learning, Power BI, data movement, streaming, and so on. Right? It also brings together some of the perceptual intelligence APIs from Project Oxford, a whole bunch of things. I'll talk about a piece of it, not all of it. The other big part of our offerings is SQL. And we recently released SQL 2016, one of the major releases in the past 10 years. And a highlight, we announced we're going to be offering it on Linux, right, in addition to Windows. I won't be able to say much about this, but I do want to stress something. It's a multi-billion-dollar product for Microsoft, on-prem for the most part, which is what you know it as. But it's very important to recognize that our cloud offerings, XLDB, XLDW, they share the bones of SQL Server in a very fundamental way. In fact, many of the features that actually were released in 2016 were baked for months previously in the cloud as part of these services. So the distinctions are blurring. Also, we recently acquired a company called Revolution R. We support open source R at an enterprise grade, and we integrate it into lots and lots of our offerings, including SQL Server, and including several of our cloud services such as Hadoop, as well as with things like Teradata. Okay? So these are the three big pieces. I really will focus on this one. And more precisely, while the suite as a whole has all of these pieces, I'll talk about the big data focus, the Azure Data Lake Store, which is really, think of it, if you will, as HDFS in the cloud. So you say, create an HDFS file, you load whatever you want, you run your queries, and it'll run in a way that's friendly to a yarn-based service. So for example, you can look up where your data blocks are. Okay? And I'll also talk about, on the analytics side, our Hadoop offerings, including Spark, Storm, HBase, the whole lot. We recently announced support for Heron, working together with Twitter. And I'll talk about Azure Data Lake Analytics, which is something new that we've been incubating in public preview for a few months now. So this is the focus, but I want to mention that there are many other pieces that I won't have time to get into. SQL Data Warehouse, which is a Redshift-like offering, Data Catalog, Data Factory, which is really a data movement service, Event Hub, which is like Kafka, a machine learning suite, Stream Analytics, and various other things. Okay? But let me begin by explaining what it is by illustrating what you get from it. You can create a dashboard like this. I'm not going to go into it in detail, but let me call out a few things. The underlying data is a combination of traditional relational tables, various kinds of documents and news feeds, various kinds of financial feeds, so streaming, as well as static data of all types, right? Not just relational. If you look at what is on this dashboard, you have the traditional kind of reporting views, right? And behind each of these, there's a SQL query. To be specific, it's a uSQL query, which I'll get to in a moment. It's a variant of T-SQL, Microsoft's SQL dialect. These streams are being processed in real time using a combination of Spark, Azure Stream Analytics. Right? Here, you're seeing various alerts that are flagged by doing machine learning on these real-time streams in context with some of the stored data. Right? So there's a whole lot going on here. Streaming, real-time processing, including Lambda type ML, as well as the usual kind of BI roll-up, drill-down kinds of views you would expect. Now, you can look at this. In fact, let me go back. This suspicious trading alert, you can click on it. In fact, you can click on virtually everything here. This is a real screenshot. Okay? You can click on virtually anything here. Let me illustrate what happens when you click on that alert. Here's a further refinement. Why was it suspicious? A whole bunch of breakdowns. Again, everything here you can interact with. Okay? You get the idea. That's one kind of interaction. The other thing, from a developer perspective, as I mentioned, many of these have SQL queries running. If as a developer you see something odd, you can try and debug that. Now this is the geek's view. Right? You're looking at a snapshot of the actual execution. In fact, later on I'll show you can actually see a replay of the execution in real time from many, many perspectives. You can look at the structure of the computation from the lens of execution time, from the lens of I/O, from the many different perspectives. Okay? So both from the standpoint of the consumer of all of these data products and from the perspective of the cook, the developer, what we want to do is bring all this together seamlessly, give you the ability to drill down to any level of detail you want. Okay, what's behind all of this? I'm not going to go into this in gory detail, but this is sort of the high-level architectural architecture that captures where we are headed. More than the architectural aspects, there's something I want you to take away from this. That's an answer to our big picture strategy. We have made a bet to be open. For Microsoft, this is perhaps an unusual statement, but not so much. Over the past few years, many of you, I think, have come to recognize that. In this space, Hadoop, R, Jupyter Notebooks, we are heavily vested in all of them. Right? And in the case of Hadoop, open standards like Yarn, we work extensively with Yarn. And in the case of Yarn, everything we do is contributed right back. I'll use the term Yarn++. Well, on some slides I will, to indicate that this is the version of Yarn that we are using, but everything in the ++, it's on its way into open source with maybe a lag of a month or two. Right? In fact, some of the things, Mercury just got into Apache trunk this past week. Okay. Likewise, when it comes to storage, we standardize upon HDFS. In this case, rather than use open source HDFS, we have built out a cloud service, Azure Data Lake, leveraging some of the assets we have in-house in something called Cosmos. Again, I'll speak to this in a little bit. But net of it, from the standpoint of any applications, you see HDFS, you see Yarn, and therefore, you can run as an application master anything. This includes MapReduce, it includes Tez from Hortonworks, you can run Spark this way. Our own stuff runs as an AM, right? So from the end user's point of view, they can mix and match all of these different things, some unique to Microsoft, proprietary, others just from open source, the actual open source bits from your favorite distribution, right? And they mix and match. We offer these in two form factors. You can run it as a service. You submit a query and you get results. This is how we operate it internally. This is similar to BigQuery, for example. Or you can run it in a cluster form factor. That's HD Insight. Build me a cluster and then do all these things on my cluster. We support both. But all of them, at the end of the day, will look similar stack-wise. Okay, SQL DW, HD Insight, other Azure IaaS services, while they may not use some of our runtime, they all will leverage our Azure Data Lake storage services. This itself, as I said, derives extensively from some of our Cosmos assets. I'll speak more to that a bit later. All right. I think the easiest way to think about our big data offerings is not in terms of each individual piece, but in terms of the whole. I personally think of this as the evolution of data warehousing. Historically, data warehousing has been something we practice for our highest value data. We go top down, right? We understand the things we care the most about. We have deep semantic models coming out of business analysts. Then we take this, do everything from setting up the infrastructure, ETL design, ETL schedules, the dimensional modeling that leads to your cube, and then the reporting and the pretty pictures that come on top, right? This essentially is the classic relational warehouse. It's really good for certain things, but what has also emerged in the past several years is this notion of a data lake, where you just grab anything and everything, right, and just stick it in there. And because it's coming at you so fast and the volumes are so large and the sources are so diverse, you don't have the luxury of ETL. You just grab the sucker and stick it in there. And then you interpret it, right, on the fly as needed. So a corollary of this is it's both enabled and requires much richer, much more diverse analytics to make up for the fact that there isn't a lot of curation going on when you stick the data in there. Okay? And so this is more bottom-up. This is useful when you are storing data speculatively, when you're looking for insights or ahas, as opposed to tracking some known processes to see if things are on track. Okay? So that's the bottom line. I don't see these as disjoint, the traditional and the quote-unquote data lake approaches. I see them as complementary. And in fact, depending on who you talk to, either these are complementary technologies that are deeply integrated side by side, or in fact, one will evolve to support the other natively. So for example, if you look at, say, Impala running over Hadoop data, they would argue that, hey, the relational query processing you're doing can be done right here. Those details aside, this, I think, is what we are striving to provide as part and parcel of the whole Cortana Intelligence Suite, right? The whole diversity of analytics, the diversity of types of data, diversity in terms of how the data is arriving at you and the modality in which you want to process it, interactive, real-time, whatever, right? That's the picture. Okay, so much for the motherhood and apple pie. In doing this, I also carry a pager, right? So the job.
So it's actually interfering with the audio, the cell phone or something? Okay.
As you can see, real-time data feeds can be complicated. All right, so let's come back. That was probably my pager going off. Jokes apart, the thing that keeps me busy the most is my responsibility for running big data at Microsoft. This has two parts. The external part, Azure Data Lake, Hadoop, HD Insight, all of this you know about. The internal part, Microsoft has been doing this for 10 years. When I went over from Yahoo, where we did some pretty large-scale stuff, we birthed Hadoop there in the early days with Doug Cutting and others. In spite of that, I was staggered by the scale at which the Microsoft big data stack operated, even when I got there. There's a file system called Cosmos, which is similar to HDFS. And there is a query language called Scope, which is similar roughly to, say, Hive, except think of it as a combination of Hive/Pig/MapReduce. Okay? User code is a very big, prominent part of it. Net. This is the backbone for Microsoft today. It is our internal data lake. And you can't name any part of Microsoft, frankly, that does not rely upon it. And if there's even a 10-minute hiatus in something, it is several, let's say a lot of money, okay? And therefore, lots of pages going off. Xbox, Bing, Exchange, Windows, ads, Office 365, Skype. Every single one of these relies upon these services and relies in a very fundamental way. In fact, the notion of data warehousing has morphed. They use it so fundamentally in what they do. It's part and parcel of their cadence. The volumes of data. There are thousands of developers internally who use this. We run hundreds of thousands of jobs every day. The daily I/O is in the hundreds of petabytes, right? The amount of data we manage is in the exabytes. The largest Hadoop cluster I'm aware of is 4,000 or 5,000 nodes. Our smallest cluster is tens of thousands of nodes, right? This is the scale at which we operate. And everything I'm telling you today is grounded in this experience because the path we are on is a converged stack. Our internal data lake and our external data lake are headed to be the same stack, okay? So the lessons we took, some of these are fairly obvious. Handling failures natively from the ground up, sharing data, resources creates a virtuous cycle, which makes everything bigger very fast and also much more useful. You need to leverage parallelism, of course, and you need to be very data aware in virtually any decision you take. The one part I want to stress for this audience, for someone like me coming from an academic background, this was a thing that has taken the longest to really internalize. The importance of things like security, compliance, governance, right? You cannot move data from one location to another, where location might be one rack to another, let alone one country to another, right? For reasons of compliance boundaries. And there are all kinds of legal issues attached to this. So dealing with all of this natively from the ground up is a big part of what we are doing to go from an internal stack to an externally available compliance stack. I'm happy to say that we got some good buzz. Forrester, and I like to call this the US News and World Report college rankings for industry. And I learned from Mike Stonebreaker that top right corner is the place to be in all of these 2x2 grids. So I'm very happy that we are in the top right corner for big data solutions. Okay, now let's switch over to a slightly more technical view of all this. I think there are two questions I'd like to put in front of you. Yesterday, you had a lot of discussion around tiering. That was spot on. A key question is, where should the data be? And I see two competing forces at play here. With the growth in main memory and the desire for interactive real-time exploration, there is a premium on low latency processing, right? Conversely, with sensors, the volumes of data we are talking about are huge, right? And unlike the web, where a handful of companies really produce massive amounts of data by observing web logs or search logs, tractors today, if you look at the cockpit of a fighter jet, it's probably simpler than the dashboard of your typical state-of-the-art tractor, right? As it walks and as it goes down a row of plants, each plant, the amount of fertilizer injected depends upon the soil acidity of neighboring plants, rainfall over the past week, the stars of the zodiac probably. The volumes are ridiculous, right? You need to be able to store that data inexpensively. Yes, you're processing it really, really fast as it arrives, and maybe for a little while longer it stays warm, but you need to be able to store this data long term, right? And increasingly people want to store the data long term because there is very inexpensive storage if you store it offline. So on the other extreme, from in-memory processing, there are people building dedicated data centers for cold storage, right? So clearly there's an issue here. From the standpoint of a customer, they don't care. Their concern is, hey, I need to be able to store data cheaply most of the time. When I need to process it, I'm willing to pay for whatever it takes. And oh, please, once I tell you how to authenticate and ACL my data, please take care of the rest. Asking them to schlep from one silo to another means, among other things, for example, it gets across different compliance boundaries. These are the kinds of things they don't want to deal with. So how do we accommodate all of this? How do we take responsibility for something that database people have historically done well? A database essentially moves data from disk to the main memory buffer pool, going back to the oldest days. So all this basically means tenure for life for everyone who's a database person. It's all about memory hierarchies. But now the volumes of data, the types of usage scenarios have all grown explosively. How then do we do buffer management, quote unquote, in this era? And buffer management, not for one query engine, but for a whole fleet of query processing. Okay, there's another second fundamental question to think about. Increasingly, you need to figure out where to place your computation, right? Data doesn't always get pulled in. You also take your computation and move it out to where the data is, right? There is this blend. You may do some anticipatory data movement, but also the volumes are such that if you have 1,000 machines, we have queries, by the way, that run in production daily on 10,000 machines, right? At that scale, if you're schlepping data across these thousands of machines willy-nilly, you're toast, right? If you're doing hundreds of petabytes of I/O a day, that's only possible because the vast majority of it is machine local, then rack local, right? And that's because you very carefully lay out your computation based on data affinities. So how do you do this? This is where the era of resource managers is now upon us. Keep in mind that you also want to be able to reconcile many different types of engines, often developed independently. Here's where things like Yarn enter the picture. All right, those two questions I will speak to briefly, starting with the first. Azure Data Lake Store is a fully managed HDFS compliant store, right? You can store files of any size, and you can correspondingly get high throughput. On ingestion, unlike traditional HDFS, you can select for high IOPS as well as high bandwidth. And you can read a file as you're writing it. You don't have to seal the file. As extents are sealed, they become available for reads, right? This is very, very common in IoT type scenarios and simplifies your use of event brokers a fair bit. Authentication, as you would expect from Microsoft, is based on Active Directory, in particular the Azure version of Active Directory. So if you have, if you have AD-based authentication on-prem, it's very easy to get that in here. All right. ACLing, you get full POSIX, file and folder directory structure with POSIX ACLs. The data is encrypted at rest and shortly in motion, right? The keys can be managed either by the client or using a key management solution. You have the options. Let's look at this architecturally, and I'll try to just at least hit on the highlights. The endpoint is what we call a secure store service. This is where a request goes. The first thing that happens is it does a file name translation. So right here, files have a logical name that maps into this directory structure and then gives you a physical location. Once you know that, you check all the encrypted authentication keys. If the request is properly authenticated, then you can look at the extent metadata to figure out exactly where the data is laid out across all the tiers of storage, across all the different machines. In fact, this is very useful because when an AM needs to create a plan that is based on data locality, it can interrogate an API here to find out where the data is, in pretty much the way you would talk to the name node in Hadoop. Okay. All of these are managed using HA Cloud Services based on Paxos rings. This is some of the stuff that we have painfully refined over the past several years of running Cosmos. The actual data can be stored in Windows Azure remote storage. right? We stripe it in order to get high bandwidth at will for a given request. So prior to this, a common pattern for us, customers like Skype. Skype, by the way, moves more data across the web than Netflix, I believe, right? These guys, they were essentially doing their own striping because they could not get the bandwidth, the sizes they needed from any individual Azure account, right? Now, this is the basic architecture of ADL. Now, let's go back to this point I made, tiered storage. How does all that translate into this scenario? Fairly straightforward. In the compute tier, as opposed to the remote storage tier, you can again have a fleet of machines. These are the same machines where the computation is going to happen. Here's where the VMs are allocated for compute. But those same machines can now also have data cached. This caching is done seamlessly by ADL. And when you allocate VMs, right, the U here, by the way, is a bit nuanced. I'm talking about the developers of the AMs for the various engines I talked about, not the end user. Okay? In implementing SQL or Hive or whatnot on this framework, those AMs can talk to the extent metadata service to figure out which machines have the data for a given query and ask for VMs situated on those machines to avoid moving data. So when data is in the compute tier, you can co-locate. When data is in a remote tier, you can stage that data movement ahead of time if you want. And if not, it's like a page fault. You do have lower, slower access, but nonetheless, it'll work. It's a page fault. Okay. Moving on, let's look at the compute side. HD Insight, you know about already. Okay? Managed, monitored, supported. Basically, you pick the cluster size. You can change it. You can say grow it. We'll do it dynamically. You can say shrink it. We'll do that too dynamically. But you make that call. And you basically, the meter is on. The number of machines you have, we are charging. Okay? However, we take care of any issues. We update, patch, secure, do all of this. So it's a fully managed cluster service. The advantage here, we give you a whole slew of things that you get off the shelf, but you can also install custom things that you are interested in if you so want to customize your cluster. It's full Apache Hadoop. In fact, we have a partnership with Hortonworks, and we essentially use their bits, and you get Spark, you get Hive, you get HBase, pretty much whatever. All right. Let me show you a simple application that might be of interest to this group. This actually runs on HD Insight. It's from the eBird project, a long-running project at Cornell, to crowdsource data. So if you see a spotted hornbill, I don't even know if it exists, in your backyard, you apparently can register this observation. So over the years, this is the largest crowdsourced database of ornithological observations. And they just issued or are going to issue a Department of Interior State of the Birds report, which is trinational, Canada, Mexico, US. And it's based on this. This is an animation, right? Tree swallows down to within a kilometer, square kilometer, and a few hours, observations of where a swallow was spotted. And they have this for many, many species. As you can see the migratory pattern. Over time, the heat map shows you how the swallows are moving up and down, right? And on the basis of this, they set policy, they set programs. For example, this is the migration path. Here, I want to incent farmers to harvest a month later. And for that, I will offer them monetary incentives, and I will give it to the farmers who bid, the best bid. Right? These are real programs based on this kind of data. Okay, that's HD Insight. That's the cluster form factor. Come build me a cluster, let me have a party, and let me run whatever I want on it. Internally, in Scope and Cosmos, the model we have is, hey, stick my data in there, here's my query, give me the result. you don't think about a cluster. It's more like BigQuery, right? You have this large array of pre-existing fleet of machines on which you run anyone's query. I have run out of time, but let me just be brief here. Like everything, Apache Yarn scales dynamically. This is really the derivative of the scope language, except useSQL is very closely aligned with tsql. With the delta being, we allow you to write C# code to do all kinds of customization and to do all kinds of custom reductions of your partitions, right? You just log in, create an account, you can submit a job, no notion of a cluster. The data can be in ADLS or Azure Blobs, or for that matter, XLDB. These are complementary, obviously. And the language itself, I will not get into in the interest of time, right? The main thing I want to point out here, it is extremely powerful for data preparation, given your ability to write C# code and have it be massively, massively parallelized. Okay? And at the same time, it is SQL. So the optimizer is going to do its best to estimate various aspects of your stored procedures and user code and do the right thing. Okay. It has federated query processing. Your data doesn't have to be in any one of the sources. It can be in a variety of them. Its native source, of course, is ADLS. Lastly, there is a notion of stages similar to the algebra underneath. And based on this, there is this very, very powerful Visual Studio integration. And that's the animation you saw, right? You can look at progress. Green is done, blue is working. You can look at execution time. You can see a heat map, and so on. There are many, many attributes that you can look at. Every job is recorded, and you can play it back from any of these myriad perspectives at any time. There's an actual video, which I will skip in the interest of time. The last thing I want to briefly touch on, in terms of where to schedule data, as I said, we use Yarn. Let me get past all of this. It's part of useSQL as well. And this is the slide I want to put up and then pause here. We have made contributions to everything from preemptive admission control to predictable resource allocation, both of which are already in Apache Hadoop. Mercury just recently got into Trunk, right? This, in Cosmos, one of the unique things we had was greedy allocation. We integrated that with Yarn. Federation. As I mentioned, we run on tens of thousands of machines. A typical Yarn cluster is 5,000. How do you reconcile this? We federate. To the Yarn job, it looks like one cluster. Underneath, there's a slew of interesting issues going on, right? Federations can, in fact, be across data centers. Framework pooling for interactive computations, right? All kinds of cool stuff going on. I invite you to come take a look. Virtually everything we do here is in open source. We file JIRAs at a very early stage and code develop. We would love to see you also jump in the pool. So let me stop here. I promised Magda I'd leave time for questions.
Thank you. So we do have time for questions. So any questions from the audience? Yes.
Yeah.
How would you describe Microsoft and open source? I mean, as you develop cloud, there's Amazon Cloud, there's Microsoft, there's Google Cloud, and one of the challenges that enterprises have is they may end up with one or more cloud because some components of certain cloud might be much, much better developed than others. How close or far apart are you from open source? I see that you are embracing a lot of open source, but where are you not embracing open source?
It's a great question. I think this is how I would try and answer it. Open source, when you embrace it, you either do or you don't. There's no such thing as almost pregnant, right? So HDFS, our storage system supports HDFS, period. Yarn, we actually use the actual Yarn open source bits, right? Hadoop, we run the exact same distribution as Hortonworks, which is an Apache open source set of bits. The interesting point is this. In this ecosystem, there are some standard interfaces like HDFS and Yarn. And if you build something new, so Hive was developed at Facebook, Pig was developed at Yahoo. Both use HDFS to store data, and they can schedule underneath with a resource manager such as Yarn. As long as you use the common sockets, 2 jobs, 1 Hive, 1 Pig, possibly from different users, can run on the same machine on the same data. This is the principle we use to interleave our own proprietary engines like uSQL with open source. So the underlying data is stored once in a very open way. You can consume it using your favorite open source tool, exactly open source, no shades here. Or you can use it one of our tools, and you can do this concurrently if you wish.
Other questions?
And our coverage of the open source tools we support, we try to make it as broad as we possibly can. So all the Hadoop things, Spark, in terms of Python, R, in terms of notebooks, Jupyter, we are pretty comprehensive. Yeah.
So very quickly, you mentioned that Microsoft is, as a sort of a cloud vendor, is getting a lot of demand now, or is at least beginning to see demand pick up on kind of the Internet of Things, sensor-driven data, and things like that. I'm wondering, the SQL sort of paradigm, you might say, for analytics is sort of, it's very business-oriented. Its background is, it's OLAP, it's MOLAP, it's that sort of thing. But when I talk to sort of the scientific community, a lot of what they want to do with machine-generated data are things like image processing, convolution neural nets, time series analysis, and things like that. I'm wondering, just as a sort of a, throw the dust in the air, what do you see as being the direction of SQL with respect to that class of analytics, doing, weighted time series segmentation and things like that?
Yep. So if you take, it's a nuanced answer, I think. If I take a snapshot of where we are today, compared to the classic do relational queries SQL Server, we've come a long way. So in 2016, for example, R is deeply integrated. So you would run R in proc inside SQL Server, right? So in order to run R, you don't need to take your data out of SQL Server. On the other hand, can I say exactly the same for your favorite convolution library? No, right? Will we go there? Perhaps. Depends on the degree of pull we get. But at the same time, that's the sweet spot for the data lake side of things, right? So these are indeed something complementary. And just how deeply they intertwine depends on the customer pull we see. Yeah.
One more question.
Yeah, I hope.
So you made a passing comment a few slides ago about baking a lot of the features in SQL, you said SQL 2016, in the cloud first, and
Yes.
then bringing it onto the shrink wrap software that you're putting out.
Yes.
And in the past, it's, I guess it's been the other way around. You started with SQL and you brought that into the cloud. So can you talk a little bit about how those lines are blurring in terms
Sure.
of the development process for the database
Sure.
services as well as the shrink wrap software?
So one simplistic answer would be big chunks of the code base are identical. And for example, if you take a new feature that appeared in SQL 2016, very likely it was pushed out into SQLDB on the cloud at least 6 months before. Okay? In the cloud, our pushes are very frequent. Okay? I'm not sure I can tell you exactly how frequent, but very frequent. Certainly way more frequent than the historical box release cadence. This allows us the agility to do what I just said. There is a nuance that is a bit simplistic. The code bases are not identical. If you take SQLDB, for example, there are pieces in there that allow it to natively shard and multi-tenant small databases across many, many but a small number relatively of SQL Server instances. Literally, we have millions and millions of databases that we are managing in the cloud, and we're not running millions and millions of instances of DBMSs. That is not a feature that you would see in the on-prem, but some software engineering allows you to layer that on top of the core. Yep.
So maybe one last question as
Yes.
we're switching speakers.
Yes.
Hi, Martin. So Microsoft finally embraced the open source to do cost reduction of software development. Great. Applause. Finally.
Thank
But
you.
now, is your ecosystem also open? So actually I can come in with my open source product and actually tap in all your nice goodies? And what's the cost?
Yeah. So that's a great question. And I'll give you, I think, a work in progress answer. Okay? The yes part of the answer is, let's take HT Insight, right? It runs totally open Hadoop bits, and we make it easy for you to take your custom, let's say you developed, Giraffe++. You can bring that in and run it on HT Insight exactly as you would do by downloading Apache Hadoop onto your desktop and running it, okay? And we make it easy for you to then publish a gallery image of how to do this so others can do the same. The not yet part, if you take the data lake picture I showed you, where Yarn and HDFS work together to let you build an arbitrary AM, those interfaces, we are not exposing all of them externally today, right? Virtually all the HDFS interfaces are externally exposed. The Yarn interfaces are for internal development, right? In the fullness of time, that could change, but as of today, not yet. So, short answer, if you wanted to get your stuff running in that setting, it would have to be a specific BizDev arrangement. And if what you're doing is interesting enough, we'd engage with you, right? But we don't have the ability to scale that kind of engagement yet, and so we're moving cautiously. It's more a matter of our maturity in doing that than a desire.
All right. Thank you, Raghu.
You're welcome.
Thank you.